Well, greetings, Mr. Kolazar's class. Today we're going to start looking at naming and writing of our ionic compounds. So we're going to be knowing this as chemical nomenclature is the beginning of this term. Nomenclature is the way we name and write our chemical formulas. So to begin with, we're going to look at today writing our chemical formulas of ionic compounds. And so with our ionic compounds, we're going to be thinking about them as having a positive and negative part, a metal and a nonmetal will be combined together. So first off, we're going to look at the ions that are used to form those. So a monoatomic ion, an ion made up of one atom. So like sodium with a plus, iron with a +3, oxygen with a -2, all of those are just ions of one atom. Remember, an ion is either a charged particle, either positive or a negative charge to it because it's either gained or lost electrons. For naming of our monoatomic cations, remember cations, cats have paws, there are positive ions. We're going to give the element name and add the word ion to it. Now, we have a special case that we're going to see is if it has a Roman numeral. Our number sign. So our Roman numerals include this now are only going to be needed if there's more than one possible charge for a transition metal. We're going to include lead and mercury in there. So normally we're just going to name the element and add the word ion, but if it's a transition element, anyone in the middle block on the periodic table, or lead or mercury, we're going to have to include the charge with it of what it actually is with a Roman numeral. And we'll look into that in just a minute. So naming of monatomic cations, again the idea, Roman numeral, only if it's a transition element. So if we were to look, an example here would be sodium in group 1. Sodium on your gold packet periodic table, if you don't have that out, grab that out now. Look up in the upper right hand corner. Sodium has a +1. So you don't need to use a Roman numeral. We're just going to have it sodium Na would be a +1 charge. Don't need to write the ones, we assume that they're there. Now an example of a transition element from the middle block in the periodic table, when you look, iron can have a +2 charge, or iron can have a +3 charge. And in that case, if there's more than one, we're going to use a Roman numeral, like iron would be a +2, or iron would be a +3, and we're going to have to find out which one it is as we're going forward. So to write the symbol for each cation, so magnesium is in group 2, so magnesium Mg, and it's going to be given a +2. Iron is one of ours that is in the transition elements. So in this case, iron with a Roman numeral 2 would be iron with a +2. Copper 1 ion, copper with a +1. Now silver ion, if you look at the periodic table on your gold packet, silver only does have one possible charge. It'll always be Ag with a +. So you note that there's no Roman numeral with the silver. Potassium, part of group 1. Potassium will have a + charge. And molybdenum, our Vi is a +6. So molybdenum, Mo with a +6 charge. There are a lot of different charges molybdenum can be. Now if we go just the opposite way, if we wanted to have the ion and have to give the name, we could look through the entire list first. Iron, a transition element. Lead, a transition element. It's included in there with mercury. Zinc is, and tin is. So if there is a transition element, we need that Roman numeral. So if it's not Na+, it would just be our sodium. And since it's the plus, sodium ion. Iron, transition element, +3, so it's going to be iron Roman numeral 3 ion. Aluminum, ion, only can be the +3. Lead's a +4 in this case, so it would be the lead 4 ion. 1 before 5 is how our Roman numerals are written. Zinc can only have a +2 charge when looking at it on the periodic table, so you could either write zinc 2 or just the zinc ion, as we're getting familiar with that. And then Sn, tin, +2, so we're going to give it tin 2 ion. So when it comes to our naming of our ions, we can see that if it is a transition element, we need to have that plus charge written down using a Roman numeral. If it's not a transition element, we don't need that. So to help out on your gold packet, anybody in group 1 wants to lose 1 outer electron, we're going to give them a +1. Group 2, 2 outer electrons wants to lose +2. And group 3, 3 outer electrons +3. Down below here, groups 3 through 12, our charges vary. Since they vary, we need to find out, like copper can be a +1 or +2, iron +2 or +3. We used molybdenum earlier, +3 or +6. So as we're going any of those, we're also going to include tin, lead to that list. Now just the opposite, anions. Remember, anions, a negative ion. So when it comes to them, we're actually going to change it up just a little bit. It's the root of the element plus IDE. We don't actually need to include the ion. By putting IDE there, it automatically tells us that we have an ion. Roman numerals are never needed for our anions. So fluorine with a negative charge becomes fluoride. So we've dropped the end, kept the root, and added IDE to it. So fluoride tells us that we're now the ion version of fluorine. Oxygen becomes oxide. Take the root and add IDE. Nitrogen becomes nitride. And iodine becomes iodide. All of these are anions. We don't need to say ion at the end. By putting in the IDE at the end, explains or tells us that we're an ion of that element. So, looking at your periodic table, a couple things we're going to look at. First off, our transition elements don't have any bonding. And then if we look, fluorine only 1, oxygen -2, nitrogen, we can just take all of those other ones out and leave just the top one, the -3. You can take all of them out for silicon, but we're just going to go with phosphorus, sulfur, chlorine, and just stick with just those top charges. So on your periodic table, we'll fix up your periodic table in just a second. Sulfide ion, if we were to find sulfur on our periodic table, sulfur, top one, -2. So sulfide is going to be S with a -2. Chloride is an ion, so chlorine, Cl with -1. Phosphorus is going to be a -3, and bromide a -1. On your gold packet on your periodic table, everybody that's in group 18 doesn't want to combine. There's 0. In group 17, the halogens, 7 outer electrons, wants to gain 1. Group 16, 6 outer electrons, wants to gain 2. And then group 15, 3 outer electrons, wants to gain 3. Outer electrons. So as we're going forward, please include those numbers there. Now,